Hello everyone. In this video lecture we will learn about the process of remote sensing and various resolutions of satellite imageries. Okay, you all know that most of the remote sensing system are passive remote sensing, right? That means we use naturally available solar radiation in the remote sensing process. Okay, the energy that is reflected from the Earth's feature is sensed by the sensor, correct? This is a process involved in the process of passive remote sensing, right? Very important term, one should understand how these images are stored, right? The images, digital images is in terms of pixels. What's a pixel? Pixels is the smallest unit of a picture, right? If you zoom any picture, right, at one end you can see the square features, right? These are nothing but the pixels. Okay. All right. What are these pixels actually? For computer, these pixels are the digital numbers. How the value of pixels are depicted in the form of DN numbers. Okay. For example, here you can see various DN numbers, right? It varies from lower number like 40, 42, like 70, 100, like that. Okay. One thing you noted that the darker pixels are assigned with the lower, smaller numbers, and brighter features are assigned with the higher numbers, right? Very interesting. Okay. Here, for example, I say it is all these pixels are using the binary system, right? For example, if a image, satellite image or any image has 6-byte data, means there are total 256, 2 to the power 6, 256 grayscales. That means the lowest number will be 0, then you have to add 0 as well. The brightest number will be 255. That is the idea in a DN number, the pixels. Okay. Here you can see a digital image. In that you can see the pixels, right? And in the right hand side image you can see the pixels with the DN number. Okay, fine. Here the brightest one, you can have 253, you can see over there, and darkest one is 0 here, right? Correct. They are nothing but this picture, digital image is nothing but the matrix of brightness values. Okay, we can consider image as a matrix of brightness values. This is very important. One should understand before processing the satellite image in the process of remote sensing. Okay, now we will talk about various resolutions of the sensor. Like the first one, very important, everybody can understand easily, this the spatial resolution. What is spatial resolution? In the layman word, I can say spatial resolution is the minimum, the size of the pixel of the image, correct? In other words, the smallest size of the object that can be resolved in the satellite imagery. Okay. For example, I can say the resolution or spatial resolution of this image is 30 meters. That means the pixel size of this image is 30 by 30 meters. See, I will improve the resolution. I have another image with higher resolution. Look at this. The resolution of this image is 20 meters. You can see the picture little better way, correct? Then I have one more image here, the same area. So the resolution of the image is 10 meters. That means the pixel size is 10 by 10. You can see the picture even better way, correct? Now I will move to 5-meter resolution image. Okay, same area. You can see more information than the previous image, correct? Next, the resolution of this image 2.5 meter, correct? It's better than the previous one. Now, last one, 1-meter resolution. You can read what's written in the right. You can understand it's a stadium like, and you can read the writings in the stadium, right? Carpet, correct? Yes. It has high spatial resolution. That means the pixel size of this image is 1 meter by 1 meter, right? Okay. How you understood what is spatial resolution? Now it is, this particular image has a good spatial resolution, right? And next, satellite imagery has one more important resolution. It's called a spectral resolution. What means spectral resolution, right? The spectral resolution is nothing but it is capability of a satellite to sense the Earth's surface feature in different bands of electromagnetic spectrum. That means if the sensor is capable of collecting information about the feature in the visible region, near infrared region, mid infrared region, thermal region, I can say it has good spectral resolution. Normal our camera, it has spectral resolution in visible region. But whereas the satellite sensors, they have the resolution, spectral resolution in other region of electromagnetic spectrum as well, right. For example, look at this, there are various sensors. These sensors are mounted in a Landsat missions. Important thing, you can see the TM band, thematic, TM stands for thematic mapper, this one. Okay, it has many bands of sensors in the many bands. For example, 0.45 to 0.52 micrometer region, right. You can say it's a blue region of electromagnetic spectrum. 0.5 to 0.6 a green region of electromagnetic spectrum, 0.63 to 0.69 red region of electromagnetic spectrum. That means in the visible region there are 3 bands. Okay. Again 0.7 to 0.76 to 0.90 it is the near infrared region. Again 1.55 to 1.75 micrometer is again in a near infrared region. That means TM sensor has 2 bands in near infrared region. Okay. Then one more band 10.4 micrometer to 12.5 micrometer, again this thermal region of electromagnetic spectrum. It has 1 band in thermal region of electromagnetic spectrum. Then 2.08 to 2.35, again this is mid infrared region of electromagnetic spectrum. That means I can say TM sensor has 1, 2, 3, 4, 5, 6 and 7 bands. The spectral resolution of the TM sensor is capable of collecting information about Earth's surface feature in 7 different bands. Okay. It has high spectral resolution. Okay. Similarly, we have our own Indian satellite sensors here. For example, IRS-1A, the first remote sensor satellite launched by ISRO, right, in the year 1988. Okay, it carried a sensor called LIS-1, Linear Imaging and Self-Scanner sensor. Satellites carried, and it has spatial resolution. That means pixel size is 72.5 to 70 by 72.5 meters, and it has spectral bands in visible region there are 3 bands, in near infrared there is 1 band, then there is only 4 bands. Okay, that means 3 bands in visible and 1 band in near infrared. Okay. Then they improved the resolution list to spatial resolution is improved, but spectral resolution nearly same, correct? Yes, like that. Then one more important thing is radiometric resolution. That means it is capability of satellite sensor to collect information in different grayscales, and it is expressed in the terms of bytes. Okay. I say 1 bit data, that means 2 to the power 1. There will you expect only 2 scales, 0 and 1. That means the 0 means darker object, we can binary system, right? 1 means it's a brighter. Right. I say 4 bit data, that means there are how many grayscales? 2 to the power 4, that means 16 grayscales, correct? 0 is the darkest and 15 is the brightest. Okay, fine. I say another 8 bit data. 8 bit data means 2 to the power 8 grayscales. Okay, 2 to the power 8 means 256, 0 to 255, 0 is the darkest and 255 is the brightest band. Okay, last one, temporal resolution. Temporal resolution stands for how often satellites visit the area. In a year, how often satellite visits the area. In other words, I can say the time interval between 2 successive satellite visit to the area. Okay, that's called temporal resolution. And all this resolution has its own advantages. See, in a group photo is also very important functions, and also I say a individual photograph also important for your application CV, right? Again, in remote sensing, all the resolutions has equal importance depending on their application. Right, you can see various. Say this is this particular image, advanced wide field image of right. It has a high spectral resolution, but spatial resolution less. But this particular image, you can see the pyramids of Egypt. Okay, has high spatial resolution, but not the spectral resolution. Right. Similarly, there is an panchromatic image, grayscale, it is collected in the visible region of electromagnetic spectrum in one band, it is in grayscale, right? But resolution of this is better than this one. This is actually a false color composite of a multispectral image. Thank you.